The Gobi Desert stretching across Mongolia and China is a harsh, empty land, yet for paleontologists it's a gold mine. Beneath its sands lie fossils from millions of years ago. In 2023, a team explored the remote Zava Valley. A student named Nergui spotted a small bone jutting from the sandstone. What began as a tiny clue soon revealed a nearly complete, dome-headed dinosaur skeleton. The team had uncovered a new species, Zavacephale rinpoche, pushing dinosaur history back by millions of years. The Gobi had once again revealed a hidden treasure. Zavacephale's true significance lies in its age. Found in rocks dating back 125 million years, it's over 50 million years older than any other known dome-headed dinosaur. Before this, all Pachycephalosaurs were thought to be late Cretaceous creatures. Zavacephale is like discovering a forgotten ancestor, proof that these dinosaurs had a much longer history. Its skeleton gives us our first real look at the early days of the dome heads. This find pushes the origin of the group far back, reshaping the dinosaur family tree. Before Zavacephale, the early evolution of Pachycephalosaurs was a mystery. Now, we see that their signature features, small size, two-legged stance, thick skull, were present from the start. The completeness of the fossil is crucial. Most ancient finds are just fragments. With Zavacephale, we can study its full anatomy and compare it to later relatives. This lets scientists track exactly how these dinosaurs changed over millions of years. Zavacephale is a Rosetta Stone for understanding the origins of one of the strangest dinosaur families. It's a rare baseline for evolutionary research. With this discovery, the story of the domeheads is no longer just about their end, it's about their beginning. The fossil opens new questions about how and why these dinosaurs thrived for so long. Zavacephale is the missing link paleontologists have been searching for. Zavacephale wasn't a giant, it was about the size of a large dog, nimble and quick. Its long back legs suggest it was a fast runner, darting through ancient forests. The most striking feature, a thick, solid dome atop its skull, nearly 10 centimeters thick. This helmet was dense bone, not hollow, and protected a delicate face with large eyes and a narrow beak. Zavacephale's beak was perfect for snipping leaves and ferns, hinting at a plant-based diet. The skeleton was found almost perfectly articulated, meaning the bones were still connected as in life. Such preservation suggests Zavacephale was buried quickly, perhaps by a flood or sandstorm. This allowed scientists to reconstruct its posture and movement with confidence. Its long tail would have helped balance its body as it ran. Inside the ribcage, scientists found smooth stones, gastroliths, used to grind tough plants in the stomach. Like some modern birds, Zavacephale swallowed stones to help digest its food. Its weak teeth and simple beak meant it relied on these gastroliths to process fibrous plants. The presence of these stones gives us direct evidence of its diet and lifestyle. With such a complete skeleton, we can vividly imagine how Zavacephale lived and moved. Every detail, from its dome to its stomach stones, brings this ancient animal to life. Zavacephale is more than a fossil, it's a window into a vanished world. Why did Pachycephalosaurs evolve such thick, bony domes? Zavacephale shows this trait appeared early, hinting at its importance. One leading theory, the dome was used for headbutting, like modern bighorn sheep. Males may have clashed heads to win mates or territory, with the dome absorbing the impact. The bone structure supports this, dense fibers arranged to resist shock. Some Pachycephalosaurs even had necks and spines adapted to transmit force safely. But headbutting isn't the only explanation. Another idea, they used their domes for flank butting, swinging their heads into rivals' sides. This could explain why some domes are wide as well as thick. A wider dome would be better for striking a larger target. The dome's design shaped both the behavior and social lives of these dinosaurs. Whether for combat or display, the dome was central to their identity. Zavacephale's skull invites us to imagine the dramatic lives of these ancient creatures. Not all scientists agree that Pachycephalosaurs were headbutting champions. Many domes are smooth and unscarred, unlike the battered skulls of modern headbutters. This has led to another theory. The dome was for display, not combat. Like a peacock's feathers or a stag's antlers, a bigger, more colorful dome could signal strength and health. Different species had unique domes, some tall and spiky, others wide and flat. These variations suggest the domes were used for visual display and species recognition. The dome may have acted as a billboard, advertising fitness to rivals and potential mates. But the two ideas aren't mutually exclusive. In nature, weapons often double as ornaments. Think of a stag's antlers. Pachycephalosaurs may have used their domes for both display and occasional combat. The dome was a versatile tool for social interaction. Zavacephale's simple, smooth dome hints at the early stages of this evolutionary experiment. Whether for fighting, showing off, or both, the dome defined their way of life. The debate continues, but one thing is clear: the dome was key to their success. It made the dome heads some of the most distinctive dinosaurs to ever walk the earth. Zavacephale is the oldest known member of the Pachycephalosaur family, but it was just the beginning. Over millions of years, these dinosaurs diversified across Asia and North America. Comparing Zavacephale to its relatives reveals how the family evolved. Later dome heads like Pachycephalosaurus grew much larger and developed more elaborate domes. Zavacephale's simple, thick dome contrasts with the spiky, massive domes of its descendants. Some species, like Dracorex, had flat, spiky skulls, possibly representing different growth stages. Scientists debate whether these forms are separate species or just different ages of the same animal. Zavacephale's discovery adds a crucial piece to this puzzle. Its simple dome suggests the earliest Pachycephalosaurs started plain, with spikes evolving later. Or perhaps like modern animals, their skulls changed shape as they matured. Studying Zavacephale's bones may reveal how these changes happened. Each new fossil helps fill in the family tree of the dome heads. Zavacephale gives us a starting point for understanding their incredible evolutionary journey. The story of the dome heads is far richer than we ever imagined. Zavacephale is more than just a new dinosaur, it's a glimpse into a lost world. Its fossil comes from a time of rapid change, as continents shifted and new plants appeared. Dinosaurs were evolving quickly, and Zavacephale's discovery helps us understand this dynamic era. The fossil proves that dome heads were a long-lasting, successful lineage, not a late experiment. Their unique adaptation, the dome, helped them thrive for tens of millions of years. Zavacephale unlocks the hidden history of these remarkable animals. Its gastroliths confirm a plant-based diet, while its dome hints at complex social behavior. These were not mindless monsters, but social creatures with intricate lives. Each new fossil, like Zavacephale, has the power to rewrite our understanding of the past. The Gobi Desert still holds many secrets waiting to be uncovered. Zavacephale's story shows how a single discovery can change everything. It reminds us that the age of dinosaurs is still full of surprises, and the next great find may be just beneath the sand. Imagine Mongolia 125 million years ago. A lush green land of rivers and forests. Zavacephale foraged among ferns and cycads, using its beak to snip plants. It shared its world with giant sauropods, armored ankylosaurs, and early horned dinosaurs. Predators like feathered raptors hunted in packs, making speed and sharp senses vital for survival. Zavacephale likely lived in small herds, with males displaying their domes to impress rivals or attract mates. Social contests may have involved head-bobbing or, if needed, physical clashes. The nearly complete skeleton tells us about its final moments, buried quickly after death, preserved for millions of years. As the world above changed, Zavacephale's bones waited in silence. Today, its fossil lets us reconstruct not just a dinosaur, but an entire ecosystem. The discovery brings to life a vanished world of ancient rivers, forests, and dramatic dinosaur encounters. Each detail, from the plants to the predators, helps us imagine the vibrant world Zavacephale once knew. Fossils like this are time capsules preserving moments from Earth's distant past. Through Zavacephale, we glimpse a world long gone but not forgotten. Zavacephale Rinpoche is proof of how much a single fossil can teach us. Its discovery rewrote the timeline for dome-headed dinosaurs, revealing a deep and successful lineage. The nearly complete skeleton allows scientists to reconstruct its anatomy, diet, and lifestyle with confidence. Gastroliths show how it ate, the dome hints at social behavior. Each bone is a clue, helping us understand not just one animal, but the story of evolution itself. Well-preserved fossils like Zavacephale are rare treasures, offering solid data for testing scientific ideas. Studying ancient creatures helps us appreciate Earth's vast history and the creativity of evolution. Dinosaurs like Zavacephale remind us that the world is always changing, and every discovery adds a new chapter. Fossils are messages from the past, waiting to be read. Zavacephale's story sparks curiosity and inspires us to keep exploring. there are still countless secrets buried beneath our feet. Each new find brings us closer to understanding the grand history of life on Earth.